Hey folks, how are ya? Hopefully you're having a good Thursday. I am cobbling together my Thursday with copious amounts of coffee. Hey, I'm Joshua. This is my lunchtime project stream. The current project I'm working on is called BS.CHESS. It is a Twitch playable. I can just pop this up so we can talk about it a little bit. Yeah, so BS.CHESS is a no holds barred, no rules chess game played through Twitch chat. We can actually play it right now while I talk. Yes, chess Python app. Cool. So let me do something like this so you can actually see what I'm talking about. Let's slide this over here. Yeah, so it's a Twitch playable chess game with no turns and no teams. It's almost real time chess. Up to now, we have. Let me see. Let me cover some of this stuff. So the series goals. This is going to be a short series. But the stream format is to follow the software development process. So for those of you who are familiar with the traditional software development process, it is described as a five phase process. The first being the requirements phase, then the design phase, and then implementation, followed by verification, and then maintenance. And then depending upon your development cycle, like old waterfall cycles, these five phases took years, and more agile processes, I guess, compress this down to weeks, if not, for in my case, hour. I try to go through a design phase, an implementation phase, and a verification QA phase within the course of an hour. And that's what this is about. The second goal of this series is to use and understand, develop the understanding of the MVC pattern. That was accomplished within the first week of this project, so hopefully folks understand better. It looks like folks are trying to verify that whether our chess piece movement is valid or not. But yeah, the MVC pattern we have developed using that. So the model is a pretty basic model. It is just the model has 2 points of, or not, 2 chunks of data. One is the board state. So we have a 64 character string representation of the board. And also we keep a list of move history. So all of the valid and invalid moves get saved. We save the player name, the player color, and the move the player attempted to make into the history. From there, the controller is what actually handles all the logic of the game. So so basically the controller will handle the input, make sure it's valid, and then update the model, and then the view just draws the model. Right now we're looking at a view that I implemented with the TDL Python package. We also started off with a very basic console view, which just printed out to the console. We could go even further if we wanted. I'm not sure how far I want to take this project. I may wish to develop some more views. I don't know. Like, I guess my third series goal was to allow user pull requests for this view component. So we haven't quite got there yet. So maybe our work should be around that today. So let's go ahead and try to figure out what we're going to do today. Also, this is an open source project. If you are so inclined, you can go to github.com/JoshuaSkelly/bs-chess. Let me pull that up here. This is the repo for it. Yeah, pretty small project. Hopefully, it's pretty easy to understand. So the goals for today, we want to maybe better define the view with a capital V, API/interface. So that is if we want to, yeah, thanks, Gusano. Yeah, a decent amount of progress. Like we have, we force the pieces to move as they should. We have a little console log here. And yeah, it's working pretty well. Yeah, I also noticed that it will honor the Twitch, your Twitch name color if you've set it. If your Twitch name color is unset, then you just get that gray color. We also visualize invalid moves by darkening the colors by 50%. Yeah, so better define the View API interface. So what does the view do? Nice. Nice, Gisano. So what does the view do? I guess one. Um, uh, so the view draw or the view renders the model. How this is done is entirely up to the view. It receives updates about receives updates when the model is modified. It's it also sends user input to the controller. I think those are the three big things that the view does. Let's kind of talk through it, I suppose. Yep. So the controller, every time, I believe, is it every frame or is it every time the model is updated? We can take the peek at the code. It might be every time that the controller modifies the model. We let all the views know about the change to the model. So we can take a look at the controller, and so we have a perform move, record move, move to chords. This is a dirty flag. Oh, okay. So right now how we do it is whenever we get player input, we consider ourselves to be dirty, which is probably okay because we do want to render invalid moves. So if I were try to make a move like F2 D2, the chords are potentially valid. It's just that the piece residing at F2 cannot move to D2. So we do need to let the views know that they probably should render that history bit, because this is basically a representation of the board state, and this is a representation of the move history. And right now too, we send that all over. So if we look over here at yeah, so we do this publish. We send over all of the board state and all of the move history to the view, and then the view decides what it wants to do with that. So in the case of our was our TDL view. So it listens to the display event, and the callback is output. So we just receive the board and the move history, and we just have basically a cache of those that we just update. And we have this thread lock, so we don't get into a weird state. And then in the draw doesn't use that, does it? So in the draw is where we actually use this this buffer and the history. Yeah, so I think it might be easy because right now how it works is we're just using event messaging, but it might be better to have a concrete interface to implement because that's just a little bit easier as far as like API goes. So um, and actually the this can actually probably be abstracted away because whoever implements a view doesn't really care about this per se. But they care about sending events to the controller, and they care about rendering the model. So let's do that. Let's build out like like an abstract or a base class for views to implement, so they have an easy way to deal with drawing and with sending controller or user input to the controller. So let's go ahead and we have our views, and let me see. We have a console view, a Twitch chat view, and a TDL view. Okay, so we may want messaging as well, because eventually we need to communicate to the views that the game has been won, or what else? Because basically, as soon as as a king, whenever a king gets taken, it should we should declare the game over. Okay, so class TDL view. Let's just add in, I guess we can just do it at the module level. We can just say class view of type object, right? This actually too, some of this threading stuff we can push into there too. That might be a nice thing to do. Yeah, so let's just lift some of this, right? Let's just lift all of this constructor work and paste it into here. Let's add a constructor because I'm a goof. Let's correct our indentation. We need to import threading. We need to import pub/sub. Maybe this should just live in its own. Let's make a view. .py. Let's just move that instead into here. Control A, Control X, Control V. Okay. So then we have so this will have a def draw, and this will supply the I guess Gusano has won. I can run it again real quick. Yeah, I'll just let this thing hang out up here while I work. And again, folks, feel free to mess around, see if you can break it and all that good stuff. It should be somewhat board data. Hey, Dr. Robotnik. We have a new contender. All right, Gusano. And also, just so you know, there are no turns and no teams, so go as fast as you can. Draw, so pass, and then def. what else should the API look like? This needs to be something like override this to render out the board state. And then yeah, no, it's basically free for all. um, um, and how about send input? This needs I don't because right now if you look at our model, the move history looks like this, and it's a move history item. Let's go ahead and add. I'd asked folks what their thoughts about the model having accessors and mutators, and I think I think we came to an agreement that it is okay. So def add history. This needs to be move valid player name and player color equals none. The default for player name should be player, and this should basically do something like self.move history.append move history item, and this is move valid player name player color. That way we can go back to our controller, and the controller self.model.move history. Yeah, so this record move, it was, so where are we using this? We're constructing it. Yeah, we're constructing a history item here, and really the controller doesn't need to know about the inner workings of the model per se, because that kind of more tightly couples it than we'd like it to be. So what we can do is we can go to this record move, and we can say it needs to have the same signature as self.model.add history, right? So that should be move valid player name and player color, right? That's what the signature for this record move should look like. So now we don't need to construct an actual history item. We can let the model take care of that itself. And then go down here to wherever we use record move, and let me see, move equals that, move underscore valid equals false, move underscore valid equals true. We can clean this up a little bit, and then it just needs to be move valid event dot player name and event dot player color. Cool. So now this whole history thing, now we no longer need to know about the actual model inside of the controller, because we can just use an interface, a mutator that the model provides to just add a history item. And this record move actually probably doesn't need to be really used anymore, because do we only use it in just the one spot? Yeah, so we can actually we can leave this little wrapper there. It's not hurting anything, even though it's just a pass through. Okay, that should be fine. Okay. So that should fix that. Now going back to our view implementation, we have send input. Actually, this should be send move. That's the only thing we really care about. And again, this should be move valid player name and player color. And this sends move to controller. Okay. This TDL view, it has some, again, it has a lot of this yeah, so it has a run, it has a start, join, and run because it is a threaded thing. So let's go ahead and add those. These will actually be implementations, and we don't have to worry too much about like it won't be as abstract as these, because these should be overridden by the thing that's implementing the view, but these can actually be left alone, because I think a lot of the threading logic isn't going to change. So let's add a def start, pass, def join, and timeout equals 0, pass, and a def run, pass. Okay, actually let me slide this over here, and then let me split out this TDL view. I can probably just lift a lot of code. So for our start, this should all be the same. So if self.running, we're already running, don't attempt to start ourselves again. Otherwise, set ourselves to running, spin up a new thread. That's all great. On join, again, if our worker thread is none, then we're not actually running, don't attempt to join us. Otherwise, set the worker, like grab cache the worker thread, set this property on this object to none, set its running state to false, and then attempt to join the worker thread. And then run should look something like yeah, so I need to abstract some of this out. So we have like an initialization, and then we have just like a main loop. So we can do that, right? We can have a def init pass, or actually override this with the view specific init shell initialization logic. So if you're using a library, you need to set it up, do that here. So all of this TDL stuff would get set up in the init, and then in the run. So the first thing we need to do is call self.init to take care of all that jazz, and then while self.running, I can also provide an update. That's a pretty common thing. So def update comma time override this to handle buffer frame logic. Okay, so while self.running, self.draw, and then this board state should be this self.buffer, so self._buffer, and self.update time. Then I can say something like last underscore time equals time.time. Then from up here we can import time. Then we can do this is time.time minus last time, and last time equals time.time. Okay, this should all fit within that, I believe. So yeah, that's cool. Hopefully this makes this view a lot simpler. Yeah, so let's go ahead and hey Steven, I really appreciate that. Yeah, no, I appreciate the good vibes. Like, yeah, I don't know, it's like I'm in the point of development where we're trying to finish this thing, and it's hard. Like, it's like I'm facing burnout and sleeplessness, and it's been tough. This last road to finishing Delver has been very tough, and I appreciate the support. It's awesome, man. I appreciate it, Stephen. Okay, so over here, we also need to have this. We need to handle being updated from the controller. Def update. What am I calling it here? On draw board data. Update board data, and this takes a board data and a move history, with self.bufferlock, self.buffer equals board data, and self.move history equals move history. So this updates the cached version of the model. Note, this is called out of process. So that's why we have this lock here, is because this method gets updated by the whatever calls this pub sub method. So we've got to be a little bit careful with our thread handling here. That's why I'm trying to add this nice interface here, so the people who implement a view. Yeah, Steven, you definitely feel me. Like, you've been in the thick of it for a long time too, man. But yeah, so just trying to make sure that the things that touch the threading are kind of abstracted away from people actually implementing a view, so they don't have to worry about that. They can just worry about their stuff being called when they expect it to. So def update board data. Let's make this private-ish. Do refactor. And then this should be here. There we go. Let's update. This should just be board data. And this should be board data lock. There we go. override this to send moves to the controller. Okay. Actually, you shouldn't override this. This should be something. This is a Joshua task, right? Because this also needs to be threads. Well, this is a pub sub thing, so we just need to push. How do we do it? Pub sub. Display, publish, quit. Oh, there's no actual publishing here. How do I do it in Twitch chat input view? Let's pull you over here. Publish, player input an event. And then we just, oh yeah, so we just construct, we construct a player input event and then hand it off to, yeah, that's fine. And the player input event is defined, so that's fine. So up here we can say from events, import or import events. Import events. There we go. And send move. So we can say EVT equals event dot player input event. I don't think it takes any params. Then we can set EVT dot move equals move. EVT dot valid equals valid. EVT dot player name equals player name. And EVT dot player color is player color. And that should be it. That should be all that we worry about. Then we can call a pub sub dot publish player input and EVT. So this will notify the controller of our input, which is fine. Yeah. Yeah, let me kind of group all these together that I expect the players to override, or the other players, the people who choose to make a view. Okay. So this is good. Sorry, I'm not full. I just realized I'm not following my format very strictly today. But so we are deep in the middle of implementation phase. It's always the engineer in me that wants to jump immediately to the implementation phase. So I apologize. We should have actually sat down and we talked about it a little bit, but we didn't actually go through and actually set like or I guess we have goals for today. So better define the API view interface. So we want to, again, we're setting up some nice, just some nice, like a nice interface to allow the views to be subclassed and a lot of the boring work to be handled by the stuff I'm presenting. Okay, so let's see if we can get this going. So now I can say from views dot or import view, and this is a view dot view. We want to call our superclasses constructor. This stuff we don't care about. I guess we do want to care about this whole pub sub subscribe. We shouldn't need start or join anymore. We definitely need a def init, and we need to convert some of this stuff into our init. So instead of, we can't really use this context manager anymore. So let's just go ahead and have a self observer is none, and then here we can have a self.observer equals observer, nickname, password, we need a self.observer.start, a self.observer.join channel, Okay, and that should be sufficient to get us connected to Twitch. This is all happening in the init. I don't need the run anymore, but I do need a draw, right? So def draw, self and board data. This is the Twitch chat input view, which I guess is okay. I guess it's a much simpler view to implement because there is no drawing. So we just need a def update, and yeah, we can just lift all this, I believe. Paste self.observer.get events. Yeah. And then instead of doing all this event work, we can just say, so let's get rid of this, and then move equals move down lower, player name equals that, player color equals that, player color equals all that good stuff. So this is just cleaning up the player color and turning it from hex into RGB if it exists. What does our send input look like? Actually, we don't do any validation on this side. That's handled by the controller. So we just need a self.send move. That needs to be move, player name, and player color. And there needs to be a comma here. Okay. I think that should be it. Again, getting rid of boilerplate feels nice. Okay, so we don't need threading, we don't need events. All this stuff is fine. We do need we need the opposite of a knit. We need something to call to clean up after ourselves after we have closed. So we do all of our knit object knit stuff. So here we have a run self.init, last time we're running, and then maybe we'll just have a self dot, I guess, dinit, I guess, for lack of a better term. And then here all we need to do is def dinit. And I need to def dinit. Override this with view specific cleanup code logic. Cool. Okay, so then in our deinit, we just need to say self.observer.join. That should really be it. I think that should be it. Let's debug this and see if it actually is working the way we think it's going to work. So I'm going to add a breakpoint in init, and I'm going to add a breakpoint in update. Debug. Okay, so this should do all the stuff it has been doing. This is just configuring all the Twitch stuff, which seems to be working just fine. And then, cool, we are getting Twitch. Okay, so let's try. And also let me. There we go. Let's put this somewhere over here. I guess it can live. So if I do E2, E4. Okay, so yeah, so it's still getting the message, which is good. We're doing all of our fancy logic here, and then we, yeah, look, that looks to be fine. So it looks like it's a good refactor so far. Cool. It's nice to pull out a lot of this stuff that we don't like. All the threading stuff pulled out of here is nice. Cool. So let's go ahead and commit what we have, because I think this is a good place. Just to, so I would eventually like to let's maybe, I think in the last 50 minutes I can also refactor the TDL view to take advantage of the new view framework. But let's just go ahead and take a look where we're at. So git status, git add dot git commit dash m, and we are adding view base class. Again, this is all in an effort to make it easier to write views. So again, it makes it easier for me to write views. It makes it easier for folks who want to contribute to write views as well. Okay, this might change slightly because I think we also need to include the event history in this as well. But this basically was taking it from advantage, or from the viewpoint of the Twitch chat input view. Let's also refactor this one for the TDL view. So up here in our imports, we need to have from views import view. And now our TDL view is a view.view. None of this stuff needs to be there anymore, which is cool. We don't. Do we need a constructor? We might not need a constructor anymore. Let's get rid of that. We don't need a start or a join anymore. And then we just need to pull out the bits. So we need to have our def init pass, our def dinit pass, and our def draw, comma board data, and pass. And we need our def update. So then all this code right here is the initialization code. So let's cut that. And I'm being bold by cutting. And let's paste it into our init. And so we need to have a constructor to keep track of our call a superclass constructor, and then self.console equals none. And then here I have self.console. So we initialize our TDL console here, which is cool. And then for our draw, it's sufficient just to say something like self.console.clear. Let's refactor this one to have it like, sometimes you have these things called like draw internal. And then we have this self.draw internal and self.console. Okay. And then here, we can cut that and paste it here. So for each event, we can get rid of the run now. Yeah, we don't because we don't even have to touch this draw internal. We can just leave that be. That looks okay. Let's give it a run, see where we're at. TDL view has no attribute buffer. Okay, yeah. Okay, so I need to refactor this slightly. So we have this draw internal. So it's going to be, we're drawing, let's have our console be the first param, and then our board data and our move history be those params. So here we have self._board data and self._move history. Actually, we don't need board data. We can just do board data, and let's just do move_history, and then we'll just pass that as well. History. And then in our base class here, in our draw, we need board data and move history. And whenever we call draw board data, and we also need to provide the history as well. So self.move history. Cool. So draw internal takes a board data and a move history. So now draw internal takes a board data and a move history. This is it needs to be a move history. Here we go. Then whenever we see self.buffer, we need to replace it with board data. So replace. And we need to replace self.move history with just move history. Move history. Is there any other instances of this? Okay. Okay. I think we got it. There we go. And then again, so E2, E4. Yeah, we could remove this breakpoint. Yeah, there we go. So that was a pretty easy refactor as well. This is working towards getting basically a more concrete implementation of this view, so folks can do stuff with it. I think I'm kind of happy where this is at. It's made the views pretty much simpler to implement. Yeah. Let me see. So this is the view class that you will implement if you want to implement your own view. Right now, the things you're interested in are the init, the dinit, update, and draw. And I guess maybe tomorrow. Wait, tomorrow is my subscriber stream. Let's talk about that here in just a second. But yeah, maybe going forward next week, I will maybe implement a fancy pie game, like maybe juicy sprite based view, so that make it a little bit more zazzle to watch. But again, it's just gonna be just a normal view to the already established model. Okay, so I think this is looking all right. At least I want to make sure that all the ones folks are supposed to override are clumped together. And there's a description there. The send move, I don't care if it's static or not. Should we? Okay, so the last thing I need to think about for our small little QA phase here is thread safety. So we have a board data lock, but are we actually using it? So when we're updating it from out of proc, but then also maybe when we draw. So let's do a with self dot board data lock. Do all the draw logic, and then the update logic shouldn't the update logic shouldn't really mess with the underlying model data. And in fact, this cached version, I mean, you can access it if you want, but that's why we, yeah, battle chess view, definitely, Steven. Yeah, I want to have like blood splatter and all kinds of craziness. Yeah. So making this as thread safe is good because we don't want to, because basically we like this board state, we don't want the threads to be potentially stepping on each other when we're attempting to draw. Because imagine if we're halfway through drawing the board state when we get a, this gets called and updates it underneath us. That could be bad. We might lose a move. And then the next time we update, we either will be like a turn behind or we'll be off by a couple turns by the next time we update. So then you get into these weird situations where you don't quite know where things are at. So just locking, these two are the contentious bits of data. So as long as we have a lock around those, we should be all right. Okay, I think this is a good addition. We have it fairly tidy, so if folks want to try creating 2D, 3D, whatever kind of weird visualization of chess you think you can possibly imagine, feel free to attempt it. Feel free to basically here in this views directory, you can fork the code, make a new folder in here, kind of follow the two patterns I've set up with the TDL and the Twitch chat. It should be a little self-contained directory, and yeah, just go ahead and go to town if you want, and then send me a pull request. I'll take a look at it and probably merge it in. But yeah, so I think I'll be working next week on, like as Steven suggested, a battle chess version, a little bit more eye candy for you, the viewers. Because right now this has been a very fun stream for me, but I haven't had a lot of viewers, so maybe that's saying something. All right, so commit this and we'll call it a day. Or git add. We need to add. Refactored DDL view to use view base. There we go. Cool. So let me think. Bits of administrativa. Tomorrow is my subscriber day. I plan on working a big chunk of tomorrow. I plan on making art content for my subscribers. Everybody's welcome to watch and enjoy, but my subscribers, I will post probably like a Dropbox link or something in the subscriber chat on my Discord channel. So I do have one of those, Discord, so you can get access to the Discord. Actually, this probably needs to reboot this guy. My Discord channel, so if you want to have something to poke around with when prototyping, they're all yours. I'm Joshua. You can follow me here on Twitch at Joshua Skelly. You can follow me on Twitter at Joshua Skelly if you want to see what I'm up to. I do a week daily stream of this where I'm working on this chess project. I also do a Sunday stream for my main project Delver, where I do more art and shiny stuff like that. This month is September, which Twitch is calling Subtember. So if you have not subscribed to me, I would greatly appreciate that. I have 12 wonderful subscribers. Let me see, I forgot to pull up the list of them, so I need to cheat. My subscribers are what keep me going, and I appreciate them very much. They are in no particular order: Fifth Elephant, Nix Rod, Mrs. Beefy, 1111, New Obj, Neil Slichter, No Field, SG Bazzi, A Literal Train, Smith, Dr. Kegel, Glass Casket TV, and Codrake. So yeah, so if this is the first time you ever subscribing to me, you can get September half off, and you still get the same amount for me. Also, if you have Twitch Prime, you can throw it my way. I consider it like a tip jar. I don't make a lot of money off of it, but I plan on using it to, I don't know, like either attend events or maybe buy a little piece of hardware here and there. All right, folks, enjoy the rest of your day, and I will see you back probably maybe 10 o'clock tomorrow for the subscriber art stream. Take care, everybody.